Okay, so you just finished up the previous classroom where they talked about what the intercept form looks like. All interchange between intercept and factored form, but this is what it looks like. So what we'll do is we'll go through the features of all of the quadratic, how you can find them when it's in this specific form, and we'll do an example here in the black. Okay. So first of all, the end behavior and concavity. I want to draw your attention to something here. Okay. I want to draw your attention to the fact that we call that number out in front A. That's no coincidence that this is the same letter that was out in front in the previous one in the vertex form, ax minus h squared plus k. This is the same a value, so it does the exact same role as it did before. It determines whether the end behavior is going to be up and up or down and down, and whether the concavity is going to be up or down. Okay, so this is the same idea here. If a is greater than 0, then it's concave up. If it's less than 0, it's concave down. Okay, and then obviously the end behavior goes something like this. If you've got x approaches infinity, either it goes off to f of x goes to positive infinity. If it's up, and then the same thing for negative infinity. F of x goes to positive infinity. Okay. So that's if it's up. Okay. If it's up. Okay. Now, if it's down, then you just throw negatives out in front. Okay. Again, just like we did last time. Okay. This red pen's already dying here. Okay. Let's talk about the next one, which is just as easy. Okay. X-intercepts. Okay. There they are. P and Q. That's it. Okay. So again, we might write it in this form. Okay. One x-intercept is going to be P0. The other one's going to be Q0. Okay. So whatever value happens to be over here goes in here. Okay. So that's going to be really easy. It's already found it for us. Okay. So just real quick, I'll jump over to this problem here in black just so you have an idea of what's happening. Okay. This end behavior A is 3, so it's greater than 0. So its end behavior goes, x goes to infinity, f of x goes to infinity. As we go to negative infinity, it's still going up. Okay? So, up and up. Concavity, concave up like a cup. Okay? The intercepts are going to be 2, 0, and negative 6, 0. Again, I want to point out here that the standard way of writing it is going to be with a negative sign. So it's the same trick that we know before. It's the opposite of the insides. Okay? So this is 2, 0, even though it says minus 2. This is going to be negative 6, even though it says positive 6 on the inside. So again, it's the opposite of what we think. It's the opposite of the inside. Y-intercept. The rule for y-intercept for any type of function, this one included, is plug in 0 for x. Okay? That is always the rule. Just plug in, because when we think about where a y-intercept occurs for any function here, okay, it's where the x value is going to be 0. Okay, so just plug in 0 to get your y-intercept. That has not changed from the previous one. So let's go ahead and try that for this one. We have 3 times 0 minus 2 times 0 plus 6. Another trick with this is just multiply, boom, 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 all three numbers across, okay, because the x's will become 0. So let's see, that's going to be negative 6, negative 36, I believe. Okay. All right. Looks good to me. All right, so now let's talk about this next one. This is where it gets a little tricky. Finding the axes of symmetry. Let's plot what we know so far. Okay. This is our graph. We know that we've got our, our x-intercepts, and I'm doing it right below the graph just so you can see them. Okay. We know that we've got our intercepts something like that. Okay. It might be, maybe they're both on the same side. Okay. But we have no idea how far down it goes, how far it's stretched like this. That's where the A comes into play. But we do know something here. Since these guys have the same heights, we know that the axis of symmetry has to cut down in between them. Now we'll do an activity this week where we're going to look at various quadratics that have the same intercepts. Same axis of symmetry has to occur, has to go right in between them. Again, I'm not sure if you can see that in the video. Let me go ahead and highlight that a little bit more. Okay? The axis of symmetry has to go right in between those two x-intercepts. So we know what the intercepts are. Halfway between would be their average. Okay? So to find the axis of symmetry, you calculate an average of the intercepts. So this is x is equal to p plus q divided by 2. Okay? That's your axis of symmetry. That's also your h when you're going to calculate your vertex. Okay? Let's go ahead and try it over here. We've got x is equal to, well, our first one is going to be 2 plus the other one is negative 6. Okay? Divided by 2. Again, I want to remind you, opposite on the inside. Okay, so whenever you're looking at these things, think about their opposites, okay? So let's see, 2 plus negative 6 is negative 4, divided by 2 is negative 2. So the axis of symmetry for this problem in black is negative 2, okay? Vertex, real quick, before we move on to the other half of the vertex, max or min, okay? Max or min, which one is it? Well, it depends on the concavity, right? Okay, so if it's concave up, then it's going to have a minimum. If it's concave down, it's going to have a maximum. Okay? So it just depends on concavity. Depends on concavity. Okay? Depends on the concavity. Now, what about the other half? So we know that what the first guy is going to be of the axis, of the vertex rather. Okay? It's going to be p plus q divided by 2. Okay, it's going to be the average. Okay, but how do we get the k value? How do we get that second value right here? Okay, well, how would we get any y value? You plug in the x value. Okay, so I'm going to use a really weird notation here. Well, it's not weird. I mean, you're all familiar with it, hopefully. Okay, f of, and then you just plug in whatever value you got up here. Okay, p plus q over 2. So in other words, plug in this thing into your function to get y. So over here, let's just bring it back to the axis of symmetry, or this problem here in black. We found the axis of symmetry was negative 2. So what we're going to do is we're going to plug negative 2 into this equation up here and solve. So we've got 3 times negative 2 minus 2 times negative 2 plus 6. Working this out, negative 2 minus 2 is negative 4. Okay, negative 2 plus 6 looks like it's positive 4. Okay, and then we've got 3 times negative 4 is negative 12. Negative 48, it looks like. Okay, so our vertex then is negative 2 from the axis of symmetry, and then this value right here once we've plugged it in. Okay, now this is going to take some practice to get you used to this, but this is going to be the most important part of this whole section. Because think about it. Once you know what the vertex is, you know what the a value is, you can write this new problem in vertex form, and you know how to do that from the previous week. So, for example, for this problem, now that I know that the vertex is this, I can write out this problem, the same problem, write it a little bigger, this same problem in blue in vertex form. Okay? So the a value is going to be 3. Nothing's changed there. X looks like our h is negative 2, so it's plus 2 on the inside, squared, minus 48. Okay? So in blue, I have now turned this problem from a factored form problem into a vertex form problem. Now, if you're comfortable in vertex form, then by all means, finish the rest of this problem in vertex form, okay? First of all, the domain we know. Domain, unless it's restricted by the context of the problem, that's going to be all real numbers, okay? The range, what about the range? I'm going to have to switch over to blue just because the red looks like it's not showing up very well on the screen. The range is always from the minimum value to infinity, or it's from negative infinity to the maximum value. Okay, and really I should write it like this, because that is going to be part of the range. Okay, so it just depends on whether it's a max or a min, whether you write it, you know, the value, the y value right here. Okay, and remember this is k. Okay, right? K meaning this thing right here. This is k. Okay, these values goes in here. So for example, this problem right here, we know that the domain is going to be all real numbers. No change here. It's not a word problem, so we know that. Okay, the range. Let's see. The negative 48 is our. Looks like it's going to be a. This is concave up, so it's a minimum. Okay. This is concave up, so it's a minimum. So that's going to be our minimum value. So it can't get any lower than negative 48, but it is unbounded otherwise. It can go up towards infinity. Do you understand where I did there, hopefully? Increasing, okay? It, again, depends on the concavity, but usually if it's concave up, okay, then this first section up to the axis of symmetry is going to be decreasing, and then the other half is going to be increasing, okay? If it's flipped, okay, then the first half is going to be increasing, the second half is going to be decreasing, okay? And it goes to the h value, okay? So it either looks like, you know, infinity, you know, negative infinity to h, and then h to infinity, okay? Which one it is just depends on the concavity, okay? So for this one, our h value is negative 2. It's concave up, so it's decreasing first, and then it's increasing, okay? So it's decreasing first, so it's going to go from negative infinity up into our h, which is negative 2, okay? It's going down first, reaches its minimum value, and then it goes up again. So it goes from negative 2 to infinity, it's increasing. Hopefully that makes sense, okay? And again, we don't have to really, this kind of is controlled by the concavity. It really doesn't have anything to do with the type of problem it is. So hopefully that makes sense, and you can work out a problem on your own going through this whole thing. I know it looks like a lot of stuff on the board, but it's really getting to this step right here. Getting the vertex out of this guy is going to be the key component here. Because again, once you've done this, and this is something we're going to talk about in a couple weeks, if you have a form, whether it's standard, vertex, or factored form, that you are comfortable with, then the number one thing you should be focused on is how to get from the other two forms into that form, okay? Because if you can get your forms into the form you like, then the rest of the problem is easy according to you. Now, if there's certain, like if it's all the same to you, then there's obviously ones that are going to be more helpful depending on which one you've been given. So for example, finding the x-intercepts on this type of problem is very easy. You picked it out, it took you about 5 seconds to read the problem, if that. Vertex, on the other hand, took a little bit of work in the black right here, okay? Versus if it was in vertex form, it would take you a second to get the vertex from that, okay? And the axis of symmetry, as we learned last week, okay? But in this form, again, different forms give you different things, okay? So hopefully that makes sense.